Hello students. Hello and welcome to this video on binomial theorems. We will solve question number 201 to 210 and the link to download the PDF will be in description, as well as at the end I will show you how you can download and maintain updated copy of the PDF. I will also show you my question answer website where you can come and ask questions related to maths, because YouTube is not really suitable for typing math, because typing something like sigma will require Unicode and fractions are very difficult. So do join the website. Without further ado, let's get started. So that for n greater than 3, sigma is equal to 0 to n minus 1 to the power r times a minus r times b minus r times c minus r, cr is equal to 0. So we expand this, we get ABC minus AB plus BC plus CA times R plus A square plus B square plus C square times R square minus R cube. So that's what we get from this. Okay. And out of these four series, hang on, let me think carefully. How did we get A square plus B square plus C square? No. So we multiply ABC, then we get AR, BR, and then we get AC, BC, and CA into R. That is fine. Now, how did we get R square? So R into R square. This should be A plus B plus C. Because you see, you multiply these two, you get R square. And then R square, when you multiply with C, that should be C. It shouldn't be C square. So it is A plus B plus C. Okay? Minus R cube. Now, out of these four series, for ABC, R square, and R cube, first three have been proven to be equal to 0. Now, we will prove that sigma r is equal to 0 minus 1 to the power r cube, CR is equal to 0. So, we consider 1 minus x to the power n is equal to C0 minus C1x plus C2x square up to minus 1 to the power n Cnxn. We differentiate with respect to x, we get minus C1 plus 2C2x minus 3C3 x square and so on up to minus 1 to the power n and Cn x to the power n. We multiply with x and differentiate again. We get minus C1 plus 2 square, C2x plus 3 square, C3x square, and so on. So repeating this step, that is multiply x and differentiate again. So there is a mistake, I can see it. Okay. The C0 is missing here. All right. C0 is missing. So what you can do is you multiply it with x beforehand. So it is x times 1 minus x to the power n is equal to C0x plus C1x square plus C2x cube and so on. And then you multiply, then you differentiate. So you will get C0 minus 2C1. No, we don't want to C1. Oh, 0 will make C0 0, so it doesn't matter. This is correct. Okay, I went on a tangent. So you repeat this stuff and finally you put x is equal to 1, you will get minus C1 plus 2 cube C2 minus 3 cube C3 and so on up to minus 1 to the power n cube Cn is equal to 0. So apologies, the solution is correct. Question 202 says that find the value of n for which C0 upon 2 to the power n plus 2 times C1 upon 2 to the power n plus so on up to plus n plus 1 Cn upon 2 to the power n is equal to 16 is true. So we have this, so 2 to the power n is in the denominator of every term. Now we have proven that C0 plus 2C1 plus 3C2 and up to n plus 1 C to the power n is equal to n plus 2 times 2 to the power n. So we bring 2 to the power n here. So this n plus 2 will become what? 32? N plus 2 will be 32, so n is equal to 30. Question 203 says that if a1, a2 up to an plus 1, b and at, prove that sigma k is equal to 0 to n ak plus 1 ck is equal to 2 to the power n minus 1 a1 plus an plus 1. So we have a2 is equal to a1 plus b, h3 is equal to a1 plus 2d, and an plus 1 is equal to a1 plus nd, where d is the common difference. Now we have to prove this. So left hand side we write a1 c0 plus a2 c1 plus c3 c2 up to an plus 1 cn. So we substitute for all the terms the AP form. We get a1 times c0 plus c1 plus c2 plus cn plus d times c1 plus 2 c2 up to ncn. So this becomes a1 times 2 to the power n, and this becomes d times n times 2 to the power n minus 1. We take out 2 to the power n minus 1, we are left with 2n1 plus nd, which is equal to a1 plus an plus 1. Question 204 says that if small s is equal to n plus 1 upon 2, 2a plus nd, and capital S is equal to a plus d times c1 plus a plus 2d times c2 up to a plus nd times c, prove that n plus 1 times capital S is equal to 2 to the power n into times small s. So you see what we are doing here. This expression, or rather look at the solution. So we have capital S is equal to this, we expand, we get the same result here. 2 to the power n minus 1 times 2a plus nd. So you see this relationship, 2a1 plus nd and 2a plus nd. So same stuff here. Now this is equal to 2 to the power n times 2a plus nd upon 2, that is 2 to the power n times small s upon n plus 1. Excuse me, the throat is bad a bit. Question 205 says that if 1 plus x square up to x to the power p whole to the power n is equal to a0 plus a1x plus a2x square up to anp x to the power np, show that a1 plus 2a2 plus 3a3 up to np times anp is equal to 1 upon 2 np times p plus 1 to the power n. So we are given this relationship. Okay, we differentiate with respect to x and put x is equal to 1. So left hand side becomes n times 1 plus 2 plus 3 up to p times p plus 1 to the power n minus 1, because these powers will come in front of those. So x will become 1, 2, x square will become 2x, and will continue till p. And then this power will be less by 1, so n minus 1. And right hand side becomes a1 plus 2a2 plus 3a3 up to plus npa np. So left hand side, if you see, it is equal to half np times p plus 1 to the power np into p plus 1 upon 2. Okay, so p plus 1 to the power n. And right hand side is a1 plus 2a2 plus 3a3 up to np anp. So that's what we had to find. Okay. Question 206 says that show that sigma k is equal to 0 to 15 ck upon k plus 1 times k plus 2 is equal to 2 to the power 17 minus 18 upon 16 times 17. So we consider 1 plus x to the power 15, which is 15c0 plus 15c1x plus 15c2x square up to 15c15x to the power 15. We integrate with respect to x with limits 0 and x. So we get 1 plus x to the power 16 upon 16 between limits 0 and x, and this becomes 15c0 plus 15c1 upon 2x square up to 15c15x to the power 16 upon 16. So we have got this upon substituting the limits. Okay, we integrate again with x. There should be an x here. X is missing. 15c0 should have an x. Okay, we integrate again with the limits 0 to 1. We get sigma k is equal to 0 to 15ck upon k plus 1 times k plus 2 is equal to 1 plus x to the power 17 upon 16 into 17 minus x upon 16. So we put x is equal to 1 and we get 2 to the power 17 upon 16 times 17 minus 1 upon 16 times 17 by putting 0 and minus 1 upon 16, which is equal to, when you put 0, it will become 0. Now this is equal to 2 to the power 17 minus 18 upon 16 times 17. Question 207 says that show that C0 upon 1 minus C1 upon 4 plus C2 upon 7 up to minus 1 to the power n Cn upon Cn plus 1 is equal to 3 to the power n times n factorial upon 1 times 4 times 5 times and so on up to Cn plus 1. So we are given 1 minus x to the power n is equal to C0 minus C1x plus C2x square up to minus 1 to the power n Cnxn. We substitute x is equal to x cubed. So we get 1 minus x cubed to the power n is equal to C0 minus C1x to the power 3 plus C2x to the power 6 and so on. Now we integrate within limits 0 and 1. So it becomes C0x minus C1x to the power 4 upon 4 plus C2 times x to the power 7 upon 7 and so on. And right hand side is 0 to 1 minus 1 minus x cube up to the power n dx. Now we evaluate this integral. So we do integration by parts. We take out 1 minus x cube. So the other part is 0 to 1 x dot n times 1 minus x cube to the power n minus 1 minus 3x squared dx. Now this upon evaluation will lead us to minus 3n in plus 3n in minus 1, which means that in upon in minus 1 is equal to 3n upon 3n plus 1. Okay, once we have that, so give me a moment. So this will become 3n plus 1. Okay, that is correct. Now in upon I0 is equal to in upon in minus 1 times in minus 1 upon in minus 2. This should be 2. So we evaluate this integral and finally we arrive at 3n upon 3n plus 1 times 3n minus 3 upon 3n minus 2 times 3n minus 6 upon 3n minus 5 and so on up to 3 upon 4, which is equal to 3 to the power n times n factorial. We take 3 common from this from each term, and bottom is 4 times 7 times so on up to 3n plus 1. Question 208 says that show that sigma r is equal to 0 to n minus 1 to the power r, this is NCR, upon r plus 1 times r plus 2 is equal to 1 upon n plus 2. So we have proven earlier that C0 upon 1 times 2 minus C1 upon 2 times 3 plus C2 upon 3 times 4 and so on up to minus 1 to the power n Cn upon n plus 1 times n plus 2 is equal to 1 upon n plus 2. And thus we have this relationship is equal to 1 upon n plus 2. Question 209 says that prove that sigma r is equal to 0 to n Cr 3 to the power r plus 3 upon r plus 1 times r plus 2 times r plus 3 is equal to 4 to the power n plus 3 minus 1 minus 3 upon 2 n plus 3 times 3n plus 8 upon n plus 1 times n plus 2 times n plus 3. So we take 1 plus x to the power n is equal to C0 C1x plus C2x squared plus so on up to Cnxn. Now we integrate it within limits 0 and x. So we get 1 plus x to the power n plus 1 upon n plus 1 minus 1 upon n plus 1 is equal to C0x plus C1 upon 2x squared plus C2 upon 3x cubed and so on up to Cn upon n plus 1 x to the power n plus 1. We integrate again within limits 0 and x. So we get 1 plus x to the power n plus 2 upon n plus 1 times n plus 2 minus 1 upon n plus 1 times n plus 2 is minus x upon n plus 1 is equal to C0 upon 2x squared plus C1 upon 2 into 3x cubed plus C2 upon 3 times 4 x to the power 4 and so on up to Cn upon n plus 1 times n plus 2 x to the power n plus 2. Now we integrate again within limits 0 and 3. So we get 4 to the power n plus 3. Basically, this is a long expression, so I would avoid doing it. We get this. And upon simplification, we get this. So the trick is simple here. If you see, you have the factor, if you see 1 times 2 times 3 when r is 0, when r is 1, it is 2 times 4 times 5, then 3 times 5 times 4 times 5 times. So it goes on increasing, and there are three factors. So if you focus on the first one, 1 times 2 times 3, you see the first term of this expansion is C0. Okay. So one integration will give you C0 x upon 1. Then second integration will give you C0 x square upon 1 into 2. Then C0 x cube upon 1.2.1 times 2 times 3. So you need three integrations. Now next you look at this power. Okay, it is 3 to the power r plus 3. So you need x to be 3. That is why you integrate between limits 0 and 3. So that's how you solve this kind of problem. Now question 210 says that sigma r is equal to 0. It also stands true for the series which we have solved earlier. Let me show you. For this kind of series, okay, when the numbers are multiplied, you differentiate, and when they are in the denominator, you integrate. That is the trick to solve this kind of problem. So we come back to question number 210. It says that prove that sigma r is equal to 0 to n r plus 2 upon r plus 1 cr is equal to power n times n plus 3 minus 1 upon n plus 3. So you see, cr will usually have power of h to the power r. And if we integrate once, we will get r plus 1 in the denominator. And x power will become r plus 1. Then you multiply that with r, x. So CR will be multiplied with x to the power r plus 2. And then you differentiate once, so r plus 2 will come in numerator. That is the trick to solve this kind of problem. So we first integrate here, and we have this expansion. Now we multiply with x and differentiate with respect to x, which gives us our desired series. And we put x is equal to 1, we arrive at the solution. So that's the whole thing about this kind of problem. I should have explained this in the beginning, but I thought you would, my viewer, would be quite smart and figure this out. So with this, we come to the end of 210 problems. Now I'll show you my website, ashtavaktu.org, and you can download Algebra, Trigonometry, and Coordinate Geometry PDFs from these three links. The date mentioned here will not be part of PDF. This is the last date when the upload was done. So after 15 or 30 days, you should come and check if the date is updated. When you download, add the dates to your PDF file. I cannot put this date in the PDF file name because it will break existing links when the date will change. Also, coordinate geometry is available in HTML format. I will recommend using Firefox to read this because the formulas are done in Multinomial. I don't know why it is taking so long. Maybe somebody is using the server. Okay, so let's wait a bit. It should come quite fast. Usually it is quite fast. So let's wait for it to load. And also, if you want to ask questions to me, you can try my website kumdika.astavak.org. So we have tags here which you can make use of: algebra, calculus, coordinate geometry, mathematics, probability, and trigonometry. And I'll be more than happy to assist you in your problems with your problems. So it didn't load. Strange. Let's reload this page. Okay, now it has loaded quite fast. Okay. So if you see this chapter, it is all mathematical formula. And Chrome or other browsers may have problems rendering the math formulas. In extreme cases, usually they work. So try Chrome as well, and if there is any problem, report it to me. But Firefox definitely works. So make a login on Kunjika and ask questions. So not a lot of users are there, and whoever is the user is not very active. So join Kunjika and let's build a community together for students who want to learn mathematics. So with this, I will end this video here, and I hope that you have enjoyed this video. I'll fix the typing mistakes, and thanks a lot for watching the video. We will meet again tomorrow in the next video with 10 more problems. Till then, have a great day. Stay curious, keep learning, and most importantly, enjoy.